Okay, welcome to Unit 15 review, the Pythagorean Theorem, right? That was the rule that Pythagoras thought up that only works for right triangles. So we started the unit with quadratic equations. In a quadratic equation, you solve them just like regular equations. You're getting x by itself. In this case, x squared equals 9. And then x has two possible values, because 3 could go where x is, but so could -3. So quadratic equations typically have two solutions, a positive and negative solution. 0.81 plus 1.44, add them together, right? They're on the same side, so we don't have to do anything to both sides here. Decimal straight down, we get 2.25 equals x squared. Well, we know the square root of 225 is 15. So this is positive 1.5 and negative 1.5. And we're not crossing anything out. This is not the side of a right triangle. A quadratic equation typically has two answers. When you have x cubed, it's a cubic equation, right? X squared makes quadratic. So blank times blank times blank equals 8. There is only one number that solves a cubic equation. In this case, it's 2. 2 times 2 is 4, times 2 is 8. Try the other one. In this case, blank times blank times blank equals negative 125. There's only one number that can go in that blank, and it's x equals negative 5. So cubic equations only have one answer. Right, we learned all that because the Pythagorean theorem is a simple quadratic equation. So the key with Pythagorean theorem is knowing whether you're finding a leg, right? We have to square the two legs. That's the first leg. That one is just a numbering system. And that's a lowercase l if you've been wondering what the heck I'm writing there. That's the second leg squared equals the hypotenuse squared. So it says, how long is the hypotenuse? So the hypotenuse is what's missing. So 9 and 12 must be the two legs. 9 squared is 81. 12 squared is 144 equals 8 squared. We just did basically 144 plus 81. It's 225. And so the hypotenuse here could be 15 or negative 15. This is where you cross out the negative answer. Now on the test, you will just type in 15. You won't have to cross out any negative. You won't have to put in units of inches either. On pictures like this, the key is realizing you really only need one side, right? They're two of the same right triangles. But you do have to realize what's missing here is a leg, right? This length from the top of the wire down to the ground is the length of the leg of that right triangle. So the leg is missing, and we don't have to number them now. The other leg is 10, and the hypotenuse is 26. So L squared plus 10 squared is 100. 26 times 26, if you've been doing your homework, you've done a bunch, but it is in fact 676. Subtract 100 from both sides here, right? So we're subtracting these numbers, not adding them like the last one. If L squared equals 576, we need the square root of 576. Well, square root of 676 is 26. Square root of 625 is 25. This one is 24, and it's 24 feet. Now, to test, you should double check. Is 24, do I remember that right? Is 24 times 24 correct? As 576? Yes, it is. Just like the last one, but this time, the answer is going to be an irrational square root. So what's missing here is the length of a leg. So the other one is 7. So L squared, 7 squared is 49. 10 squared is 100. Subtract 49 from both sides. L squared, borrowing, is 51. So the answer is not, you put 51, it's wrong on the test. The answer here is the positive square root of 51. The negative square root gets thrown out, and you leave it that way. It says leave your irrational square root as your answer. That's an irrational square root. That's why you don't know the answer to that. Now, you could be asked to round it to the nearest tenth, and you will on the test on certain ones. So that square root of 49 is 7. So if you were asked to round it, then you might say it's approximately 7.1. And oh, they're not inches, just 7.1. All right, so again, what is missing here? A leg or a hypotenuse? Well, that's the hypotenuse. That's the biggest number, right? This is around 3.9, right? Because square root of 16 is 4. So we're missing a leg here. Then we have to do the square root of 15 squared equals 8 squared. Square root of 15 squared, 15. 8 squared, 64. Subtract 15 from both sides. Borrowing. L squared equals 49, so L equals 7. Yeah, right? And make sure that the hypotenuse, the side opposite the right triangle, is the biggest number. 8 is bigger than 7 and bigger than the square root of 15, which is around 3.9. Okay, so this is called the converse of the Pythagorean theorem. Anytime you have a theorem, which is a rule, you could sometimes have it in reverse, and that's called a converse. So we have all three numbers here. You put them in the Pythagorean theorem. The biggest number must go over where the potential hypotenuse is, right? If it's not a right triangle, it won't be a hypotenuse. It'll just be the longest side. 4 squared is 16. 7 squared is 49. 8 squared is 64. 49 plus 16 is 65. So we have 65 is greater than 64. Right, so when you have is greater than, that means it's acute. First of all, it means it can't be a right triangle, because if the math doesn't work, can't possibly be a right triangle. And in this case, when the leg side, this is the leg side, is greater, it's acute. So try this one on your own. Whoops. So in this case, is less than goes with obtuse. This can't be a right triangle. It must be an obtuse triangle. That means that it has an angle. It should have an angle greater than 90 degrees. This one is acute. It means all the angles are less than 90 degrees, all of them. So then we started finding distances. To find the distance A and B, you need to draw a right triangle. So we're going to draw a right triangle. You're going to draw it above it as well. So this is 1 unit. This is 4 units. We called the hypotenuse the distance here. So it's 1 squared plus 4 squared equals d squared. 1 plus 4 squared is 16. D squared equals 17. So the distance must be the positive square root of 17. Now, if I said leave your answer as irrational, you could leave that. But it says round to the nearest tenth. Well, this one's pretty easy because the square root of 16 is 4. So it is 4.1 approximately. And remember, distances are always positive, so we're just mentally throwing out the negative answer. Now, it's a test. You might want to double check. 4.1 times 4.1 is close to 16. I mean, close to 17. And sure enough, it is 16.81. Right, move the decimal twice is correct. So we're finding the distance between A and C. So we connect A and C. Hopefully that looks like a hypotenuse, a right triangle right there. Right, there's our right angle in the corner. So 1.2 is one of the legs. 0.9 is another leg. And that equals our distance squared. Well, 12 squared is 144. So this is 1.44. All right. And 0.9 squared, right? 9 times 9 is 81. move the decimal twice, 0.81. Let me do the other one just to make sure everyone sees that. 1.12 times 12, right? I'll do it the long way. Is 144. Move the decimal twice. 1.44 plus 0.81. Oh, we've done this one, 2.25 today. So it's 1.5 at negative 1.5 inches, but I'm just going to mentally throw away the negative one. And it's inches. Again, you won't have to write the inches on the test, right? And you better get a number, right, that's a little bit bigger than both of those, right? You're not going to get 15, right, if that's 1.2 and that's 0.9. So another distance, that's line segment CF. You connect C and F. Hopefully, if you look at the side of this, it would look like a right triangle. So this vertical side is 12 centimeters. This side is 16 centimeters. I didn't really draw that accurately. There you go. And we're finding this distance. So for this whole section, you're always finding the hypotenuse. The missing number is always there. 12 squared, 144. 16 times 16, we haven't done all that much. It is 256. And 256 plus 144 is 400. Oh, we know the square root of 400. It is 20, and in this case, it'd be centimeters. Right, so that distance between C and F is 20 centimeters. All right, so yesterday's lesson, so we're finding this distance between these 2 points. We have this point 0, 4. We have this point -5, -8. Now, you could draw the right triangle and do all that work, but there's a much easier way. To find the up and down distance, you subtract your y coordinates. So you just do 4 minus -8, which is 4 plus 8, which is 12. If you switch it around, you'll get -12, but it truthfully won't matter. But try to get a positive. So this up and down distance is 12. The horizontal distance, you do 0 minus -5, which is 0 plus 5, which is 5. So now we have the sides of our right triangle. I wrote there because things were in the way. So we have 5 squared plus 12 squared equals hypotenuse squared. We'll use D because we've been doing that. And so 25 plus 144 equals D squared. I'm running out of room, so 169 equals D squared. So D is 13, right? Positive square root of 169, 13 units. But you won't have to type that on the test. All right, so try this one on your own. So -5 minus -7 is not 12. I would expect some people to do that on the test, but it's actually 2, right? Because these are 2 away from each other on the number line. 3 minus -1 is 4. So I'm going to work over here. So let's see those 2 points before I do that. Those 2 points are right here. They're really close to each other. There they are. So it's 2 and 4. We're in that section. All right, so I'm going to work over here. So 2 squared plus 4 squared equals distance squared. 4 plus 4 squared is 16 equals D squared. So D squared equals 20. So D equals positive square root of 20. It says round that answer to the nearest tenth. So don't put 20 because it's not. So the square root of 20 is between the square root of 16 and the square root of 25. So it's 5 away from there, 4 away from there. Now here's the real question. Is it 6.4 or 6.5? I actually think it's 6.5, and you absolutely should check the 2 of them. I'm only going to do 6.5, but if I was on a test, I would do both. 5 times 5 is 25. 5 times 6 is 30, plus 2 is 32. 5 times 6 is 30. I've stepped over. 6 times 6, 36, plus 3 is 39. 5, 2, 12. Yeah, it's 42.25. Whoop, I've made a major mistake. What have I done? Oh my goodness, not 6.5, 4.5. See, I didn't make any sense once I did it. So 5 times 5 is 25. And that's how you check your work. You see if it makes any sense. Ah, there we go. Now it's making sense. Because I'm trying to see how close it is to 25. Yeah, that's really close to 25. 20.25. So D is approximately 4.5 units. All right, so we're at the practice. So try this one. Is it right, acute, or obtuse? So another way to write the Pythagorean theorem is a squared plus b squared equals c squared. Most teachers actually teach it that way. That's the way your parents learned it. So a here is 7, b is 10, c is 13, right? That's our the biggest number has to be our potential hypotenuse. 7 squared 49, 10 squared 100, 13 squared 169. Well, we have 149. That's less than 169. Is less than goes with obtuse. So are we finding a leg or a hypotenuse there? By the way, that little mark means feet. 2 of them mean inches. So what's missing here is a leg. Feel like we did 16 times 16 earlier today. I think it was 256. 20 times 20 is 400. Right? We're subtracting from both sides because a leg was missing. We're borrowing correctly. Oh, 144. So it's 12 and negative 12, but we're doing 12 feet. This has to be, the bottom of this ladder has to be exactly 12 feet from the wall. This was the wall, by the way. We've seen this picture, and this was the ladder. All right, so 10, I'm going to subtract my y's. 10 minus negative 6, 10 plus 6, 16. 8, subtract my x's. 8 minus negative 4, 8 plus 4, 12. Feel like we just did this triangle. 400 equals d squared, so d equals 20. And we're mentally throwing away the negative answer there, and it's 20 units. So a squared plus b squared equals c squared is the same thing as l squared plus l squared equals hypotenuse squared. So a is 10, b is 24, and c is 25. 24 times 24 is 576. So we're getting 676 is greater than 625, is greater than goes with acute, right? If it comes out equal, has to be right triangle. If it comes out greater, it's acute, less than obtuse. Good luck with the test. Sorry, no Easter eggs. I've sort of run out of ideas. I'm going to get some more over spring break, hopefully, and have a good break.